Are you looking to speed up the prediction phase of your TensorFlow model? If so, you're in the right place. Today, we're diving into how to utilize both your CPU and GPU simultaneously for faster predictions. I totally understand your frustration. It can be really annoying when you have the hardware available, but your predictions are still slow. You're not alone in this. Many developers face similar challenges. Let's take a closer look at your specific situation. You want to run predictions on a pre-trained Keras model using both the CPU and GPU. You've tried creating separate threads for each device, but it seems like the batches are being processed synchronously. Sound familiar? Let's explore how to fix this. So what's happening here? When you run predictions on both the CPU and GPU, the synchronization can create a bottleneck, especially if one device is significantly slower than the other. Understanding this is key to optimizing your setup. And stick around. By the end of this video, you'll have a solid understanding of how to achieve true parallelization between your CPU and GPU, and I promise it will be worth your time. To achieve parallelization between the CPU and GPU during the prediction phase, the user should first ensure that TensorFlow is set up correctly to utilize both devices. This involves configuring the session options to allow for device placement. Next, the user should modify their existing code to ensure that the CPU and GPU sessions are running independently and efficiently. This can be done by using TensorFlow's built-in functions to manage the sessions and threads. Then, the user should implement a dynamic batching strategy. Instead of manually assigning a fixed number of batches to each device, they can create a function that automatically distributes batches based on the current load of each device. Finally, the user should ensure that the results from both devices are combined efficiently. This can be done by using a thread-safe queue to collect results from both the CPU and GPU threads. Fun fact: did you know that the first neural networks were inspired by the way our brains work? Just like our brains, they can process information in parallel, which is what we're trying to achieve here. Now, let's look at the answers provided by other users. An alternative approach shared by another user demonstrates how to execute predictions on both CPU and GPU in parallel. They suggest using a single TensorFlow session with threading to manage the execution of operations on both devices. In their code, they create two threads, one for the CPU and one for the GPU, and run them concurrently. They found that running both threads together resulted in similar timing to running the GPU alone, indicating effective parallel execution. They also mentioned potential reasons for performance differences, such as resource contention, incorrect timing, or model limitations. This highlights the importance of optimizing resource usage when running predictions on both CPU and GPU. Here's a pro tip: always monitor your CPU and GPU usage while running predictions. This will help you identify any bottlenecks and optimize your resource allocation. And there you have it. With these strategies, you should be able to achieve better performance by utilizing both your CPU and GPU effectively. If you found this video helpful, don't forget to subscribe for more tips and tricks.